the abrupt cooling of Equatorial Atlantic in 2024. So the motivation for today's talk is this particular blog post, which was released by NOAA Information Bulletin Center on August 14th. I don't know if you can see the date here. This blog post read that the Atlantic mean now was on the verge of development. So this particular blog post blew out of proportion, especially among the media outlets, and this led to people, especially in the social media, start a trend that global cooling is the new hoax, which is a parody for the global warming. So to answer to this false notion, NOAA started the fact check and subsequently released a follow-up blog post after a couple of weeks on August 28th, which tells the no's and how's and why's about the Atlantic Nina and its subsequent destruction. The figures figures in these slides are borrowed from the two main blog posts that I have shown in the first slide. The figure on the left, this one, shows the box average, the box which is present over here, the eastern equatorial Atlantic Ocean. The box averaged sea surface temperature in this year from January till July, the time it was recorded. The monthly average temperatures exceeded almost 1.5 degrees centigrade in the month of March and came down to almost 0.5 degrees centigrade in the month of July. So the main motivation behind today's talk is actually trying to address what could have caused this rapid transition from a plus 1.5 anomaly to a minus 0.5 anomaly within a span of just 4 months. Mind you, the temperature recorded this year in the month of March was the highest ever recorded in the recorded history, that is from 1982 till this year. And the record low that was recorded over here is the lowest temperature ever recorded in this decade. Well, to address this issue, I have taken the help of some ocean mooring datasets. The mooring datasets are deployed by NOAA Pirata mooring along the Equatorial Atlantic Island. So I've taken the help of two particular moorings, the 0 23 West and the 0 35 West moorings, which are present here and here respectively. And all along the slides, I have used a red star for the central mooring and a green star for the western mooring. Okay. So interestingly, the mooring datasets give us the records for sea surface temperature, 2-meter UV, the meridional and zonal winds, the rainfall rate, and some other values which I'll be showing in the subsequent slides. Now, in the central Atlantic mooring, we see a nice red lines throughout the slides to represent the climatological values, and the blue slides show the values corresponding to this particular year. And I have used the time series starting from 1st of January till 1st of September. Now we see a clean evolution of sea surface temperature, where we see a good warming phase in the months of March till mid-May, and then a decline of this warm phase, which led to a cool phase in the months of June and July. So, before understanding what could have caused this cooling, we must first try to understand what controls the evolution of sea surface temperature, especially along the bands of equatorial regions in the Equatorial Atlantic in this case. Well, one fellow who controls the sea surface temperature evolution is the presence of what is known as the equatorial undercurrent. The the velocities here are taken from the Glorious reanalysis, which has data only till 25th of June. So this reanalysis dataset shows a clear signature for the eastward flowing zonal current, having a magnitude of almost 80 to 90 centimeters per second. And we see that come May, there is a significant weakening of this equatorial undercurrent. Now, this significant weakening of this equatorial undercurrent coincides with an abrupt flux of northward and westward velocities, both in the central mooring and the western mooring. So this the plot here shows the era 5 May month averaged anomalies of surface velocity curve in colors and the anomalous winds in arrows. So we see that the anomalous winds for the May month averaged shows a clear north-westward current in both the sides. So this north-westward current is thought to have caused a rapid decay of this equatorial undercurrent. How? Well, first of all, how this equatorial undercurrent sets up is you have trade winds blowing all over the Atlantic. The trade winds pile up the sea surface height over the western basin. So this causes a dip of sea surface height in the eastern basin and an upliftment of sea surface height in the western basin. This zonal asymmetry of sea surface height causes a zonal asymmetry of pressure distribution along the equator. This zonal asymmetric distribution of pressure gives rise to a zonal current, which is eastward from a high pressure region to a low pressure region, from here to here. Now, despite having northwestwardly wind, which should intuitively strengthen the equatorial undercurrent, in this case, it actually weakens. Now, what other interaction causes to weaken this equatorial undercurrent is you have the figure over here I have taken from the Martin Ray 2023 paper, which lays down the proposed mechanism for the abrupt weakening of the equatorial undercurrent. So in their article, they say that one reason which could cause the abrupt weakening of the equatorial undercurrent, despite having a northwestwardly wind burst, could be the interaction between the north-south equatorial current. Well, the name is funny because you have north and south in SEC. The north-south equatorial current is defined to be the equatorial current just below the thermal equator. The thermal equator is thought to be present around 5 degrees north. So the current just below the thermal equator, which is just below the 5 degrees north, is named as north-south equatorial current. So the interaction with the north-south equatorial current and the equatorial undercurrent is important in this case. Why? Because an abrupt northwestwardly wind strengthens the NSEC, the north-south equatorial current. The north-south equatorial current interacts with this north equatorial current. This sets in a loop which causes the circulation to enhance to the north of the thermal equator, but to reduce in magnitude to the south of the thermal equator. So this reduction in circulation to the south of the thermal equator reduces the strength of the equatorial undercurrent. So so now this reduced surface level circulation to the south of the thermal equator also has implications not only in zonal direction but also in meridional direction. We see that come May, in April to May, we see a good fluctuation of meridional velocities from a good positive to a negative values. And these have time periods of approximately 1 month. So these are characterized to be the tropical instability waves, which are present along the central Atlantic, central equatorial Atlantic. So come May, this fluctuation starts to die down or reduce. So what causes this reduction in the tropical instability wave activity is the homogenization of the pressure distribution just to the south of the equator, that is between the equator and the 5 degree north latitudes. So this homogenization of pressure leads to a reduced tropical instability wave activity. Now this reduced tropical instability wave guide acts as a barrier to any flow of water from the south of equator to the north of equator. So this mechanism was put forth by idealized studies by Pham et al. In 2023. So this barrier, this reduced TIW acts as a barrier and causes the water to pool up along the eastern and central equatorial Atlantic.
Are these two currents at the same time?
Which one?
Equatorial undercurrent, which is eastward, and this south-north that current you are saying, which is trying to reduce its strength.
Yes, that's almost like the same. Yes. Mind you that the upwelling of colder water happens all throughout the summer, as can be seen from the Central Atlantic mooring data. We see the shoaling of the 20-degree isotherm shown in the red color, and the rapid declination of the 300-meter integrated ocean heat content, which has a reducing signal from March till mid-July. So there is continuous upwelling along the central equator. That, along with the reduced TIW, which acts as a barrier to the influx of water from the south to the north, causes the water to pile up in the central equatorial Atlantic. So this can be seen when you average the SST for the month of July. So this is the SST average for the month of July. We see that the pool up of colder waters just to the maybe equator and just to the south of equator, but below the 5-degree north latitude band. Now, interestingly, we see that the plots here show the anomalous subsurface temperature, which is departure from the climatology at the central equatorial Atlantic. We see that the cooling intensifies in magnitude after the TIW weakens and the equatorial undercurrent weakens. So this upwelling of water along with TIW weakening and the fact that the equatorial undercurrent has also weakened led to the fact that there is a rapid cooling of the subsurface water, especially in the band where there was supposed to be an equatorial undercurrent at 75-meter depth. So this water caused the waters at the surface to cool down rapidly. Now, this is a mechanism which is a lot hand-wavy, because to validate this mechanism, you need to have observation currents and whatnot. But with the lack of observation currents, because I can show you that the mooring last recorded currents, the UADCP and VADCP, was only till July 2023. There is no currents recorded after July 2023. So there was no other way but to rely on the reanalysis data, in this case, the glorious reanalysis. So one way is to do a simple one-dimensional model study where you just see the effect of the vertical diffusion processes, which controls the evolution of sea surface temperature. In this case, I have done 2 trial cases for the warming event beginning 1st February till 1st April, and the cooling event beginning 1st May till 1st July. The red colors here indicate the PWP evolved SST, and the blue color mooring SST. So in both the cases, we see that the PWP shows, the one-dimensional model shows an exaggerated sea surface temperature evolution, warmer in the warming phase and colder in the cooling phase. So this raises the question that whether one-dimensional models are actually accurate enough in the equatorial region. Is there a need for sophisticated 3-dimensional modeling? So yeah, that being said, this was my effort to try to address the issue why there was a rapid cooling of sea surface temperature from plus 1.5 to minus 0.5 in the Equatorial Atlantic sector. Yeah, thanks.
Similar to what in Pacific? No.
Yeah, it should be similar because I mean, I don't know the subsurface signature, but here I've taken this snapshot of
wavelength and frequency are similar. So this is a small basin compared.
Yes.
Right?
That I have to look at. Yeah.
One comparing.
Yeah, that I have to look.
Yeah, you can see 1, 2, 3. Then.
Yep. Yeah, that I have to look. In Pacific, I guess we should see more than 3 or 4. But this is the typical signature for this rolls are the typical signature for the tropical instability waves.
Okay, another question. But anybody, I think there are papers published on impact of this on Indian monsoon, right?
There are some teleconnections associated with Atlantic.
This year, it will have impact, I don't know. Because there are few papers, including one where Murthukude talks about the same reason or some other reason. That's how curious about it.
I didn't look at it.
So there are not too many papers.
I think I have seen great Kucharski done few works on Atlantic and Indian also. Great Kucharski in Iceland.
Okay.
Yeah, I have seen a few papers.
Kaushik, so in the panel, the anomaly of temperature that section is there. So yeah, that's anomalous.
Yeah, that is much more curious. Actually, the talk should have been opposite. Instead of addressing the rapid cooling, I should have instead tried to address the rapid warming because that was much more interesting when I started to look at the observation temperature and salinity data. Because this is nothing when you compare with this. This warming event is much more intensified than this cooling event. So yeah, this will be a very good project if someone takes up as part of their MTech thesis or something.
Yeah. Okay, thank you. Very interesting. Yeah. So, play mode. Okay. So as you can see, things are going very smoothly in monsoon, and we are almost 8% above normal. And September, we are 12%. More than half is gone. So we would have, so it's going to be very unusual. I'm sure September mean will be around 10% above normal, 15% above normal, 9% except for June because of the late onset. All the 3 other months are above normal. So this has happened, although we didn't have a La Nina from that. Now what's happening in the last 2 days is interesting. We have one little low depression which brought a lot of rain to this area which had a lot of drought, and today it has moved up to near Delhi. Okay, but this will not contribute much to all India rainfall. It will be normal, but it will not be much above normal because this is a very small region. Always rain is occurring. All of India is dry. So the question is whether we are beginning to see the withdrawal of the monsoon. Okay, I think IMD is saying it will happen about a week later. Because to me, this indicates that unless something unusual happens in the next 1 week, there are no major systems emerging from Bay of Bengal or elsewhere. So I think we are seeing the end of the monsoon pretty much. Okay. Now let's look at last week's prediction. Because actual value is 14%, prediction was 13%. I would say a fairly good job, but patterns are totally wrong. Okay. I would say record this part right. That's pretty close. This was off quite a lot. And this is more or less okay. But here, entire region was deficient, but here its forecasts are not that good. And here it's pretty bad, this part. So again, we're getting all India right, but we're not getting it.
Sir, does it mean prediction didn't predict at all the professor moving over there? Does it mean the prediction 1 week ago they didn't get the low pressure going over there because exactly in the low pressure area there is.
Yeah. So what I would say is, we all think the 1 week prediction should be good at a smaller scale, but this is not showing that evidence. You're right. The very fact that they probably expected this thing to go here,
Yeah.
but it went some other way. That could be the reason, yeah. Okay, now let's compare like last week, what happened this year and last year. And what interests me is really all the rest. Up to July 31st, I think 2 years are almost identical, okay? Late, low rainfall in June, July up and down, okay, and then here comes the thing. Now, my view is, if you look at any scale more than 3 weeks and up to 4 weeks, you should be able to explain it based on the boundary conditions that are occurring all over the world. That's the essence. That's the belief, okay? But I don't see any evidence here. There was a very long break in August, and August was very active. So let's see any indicator of what's happening. Okay? This is just the anomaly in the month of August that it displays. This thing here I mentioned is still there, very warm. And El Nino is La Nina has not come here. A lot of warm here, people don't talk about. Extremely warm, and Indian Ocean also has been warm, partly global warming, partly local conditions. So, so this is one feature of this year, and interestingly, things are gone below zero. It's minus 0.21. Okay, but still, it's not going to be a line now in June, July, August, September. And what are the forecasts? Both the statistical model is here, and the dynamics model is here. I would argue, and let's look at August, September, October. I would say statistical is a better forecast than dynamic. Okay, unless it goes very rapidly. So it's surprising to me because I would think in the last 20 years, dynamical model has made great progress. You are getting the ocean model with high resolution and better simulation and so on. But the statistical models are still able to make a fairly good forecast. And let's look at CFS V2. It would have predicted by September minus 0.75. It won't happen. Okay? So almost all the individual numbers are showing around this. So CFS V2 didn't. Okay? And what is this? This is the natural multi-model ensemble of American models. And that also, I would argue, it's also 0.5, yeah, maybe close. So if you take a lot of model averages, I think errors cancel out. Now, what is surprising to me this year was that so much of cold water was there beneath the layer at the top. Okay? Everyone thought this is ultimately going to come up. All the evidence showed that it didn't happen. So that is the tricky part about predicting the El Nino as well as La Nina. Unless the upwelling occurs, you don't get this cold water. And that upwelling is a very subtle phenomenon. And this animation going from July to September shows that it came all the way here. Okay? But some of these didn't reach the surface. So that's a part where still, I think, models are not very good at. Now look at what is the forecast from INCOIS. Okay, INCOIS forecast for 3.4 for the month of August, September, October is minus 0.5. That won't be right because we have got another week, but I doubt it will be minus 0.5. Okay. Now let's look at the forecast for the next 15 days from both GFS and East ODF. Very similar. I'm very impressed that they are almost identical. Okay, showing rain here and no rain here. Okay, and so this means if this forecast is right, September will definitely be above normal. Around 8-9% we already have. Okay, so according to this, monsoon doesn't withdraw till the end of September because they're showing well above normal rainfalls in southern India. Okay? So this indicates that some more rain will be there, although today's picture doesn't show that what are the possibilities. Okay. Now let's look at SST difference in August between last year and this year. Okay. This is very illuminating. Last year we had El Nino. Okay. But remember, El Nino was confined primarily to this region, not 3.4 that much, mainly close to the coast here. Okay. This year, of course, was beginning of a La Nina, but really it didn't reach. Remember, this is small region is -1. That's what it is now. Okay. So it is difficult for me to believe that this small difference made such a big impact in August. Okay. Therefore, I wanted to focus on which people don't normally do. Look at this region. Okay. So this region of the West Pacific was warmer in 24 than in 23. Okay. And Bengal and Arabian Sea is not much. Okay. And this I've been talking about because they're both years. And so was this. Let's look at this. Yeah, this blue thing is not this one here. So the question is, are there other regions which we do not normally pay attention to are playing a role? And what Mishra talked about is there here, right? This region, Equatorial. And of course, there's a warm thing here, close to the, surprisingly close to Greenland. Okay. Now the question is, this is also their last thing, one platform. The key difference I find is this, right? And as we know right now, in the last 2 weeks, there has been extremely heavy rainfall in Eastern Thailand, Myanmar, all of them. Because this is so warm, typhoons have been forming and coming and hitting all these places. So it played an important role this year in East Asia. Question is, what role it play in the August rainfall over this issue? That issue that needs to be looked at. Now let's look at correlation. Okay, this is a 50-year correlation from NSF website, and I wanted to remember this. We talk so much about the El Nino Indian monsoon connection. There is no correlation in August. Zero. Okay. Nobody talks about it. I don't know why. If you take JJAS, it is dominated by September and somewhat in July. Neither June nor August have any connection to El Nino. June one can understand it. So on that page, maybe something is happening. But August, to me, in my mind, July and August are the peak monsoon seasons. Okay, those 2 months are the peak. June is the onset phase, the funny things happen. September is the drought phase. We don't know. The heart of the monsoon is July, August, where the very steady. Okay. Yeah. Any problem? Any question? Okay. So to me, the fact that August rainfall over India is unconnected to 3.4 bothers me. And if any of you have seen any work talking about that, it's worth asking why August and July should be so different. And especially August and September. September is the highest correlation ever. Okay. So to me, the fact that September highest correlation, to me, gives a hint that it is the Indian monsoon which controls what happens in 3.1, not the other way around. Okay. The fact that the highest correlation occurs late in the monsoon season tells you we are the other way around. And I think we discussed that. I don't know whether did you do the graduate test on this, which it was doing? Was asking whether one can show it is the Indian monsoon which controls September SST, not vice versa. It's worth looking at that part. Okay. Now this is the correlation in July. So I wanted to compare July and August. July very large, very expansive, and it's also real again. This is all interesting. This to me is again, remember, this really shows that when the Indian monsoon is very strong, the winds are so strong that it cools the ocean. Okay, the Arabian Sea responds to Indian monsoon, not vice versa in July. Okay? But you look at August, nothing. I don't know why. Okay, if August had a above normal rainfall, I expect the Arabian Sea to respond to it, but I don't see it. But I only this 50 years, I thought somebody should look at Yari for a longer period and see whether it changes, there are decadal changes this period. Okay? But it's go from 2000 to 2020, maybe it look different. So the difference between July and August is dramatic, including what's happening there. I don't know what's happening here. Let's look at water vapor, which is my, velocity potential. Now I like to look at velocity potential because it's an indicator of the upper level circulation. Okay? Tell you what's happening. Now, it was clearly between 24 and 23, there was a break in the monsoon in 23. So obviously there was descent. And Indian monsoon was above normal in August 24. So there is upper level divergence, upper level conversion. Okay. Now this is not a correlation. This is an association which will happen. If there is a big monsoon, obviously upper level conversion will be higher. If there is a big monsoon, conversion will be weaker and almost be coming in here. Okay. Sorry, divergent upper level, conversion here. So this to me is really a confirmation that monsoon is above normal. What I look at this side. This side, I want to notice a big difference between 23 and 25. Now, this is a surprise. This whole region in 23 had upper level divergence, okay? And that had some impact on the monsoon, which was missing in 24. So the question is, I don't have an answer. You think about it, because the other part, of course, was America. The 24 was going towards a large, and it didn't happen. Why does such a large descent over Equatorial America is surprising to me. Okay? It was there last year also a little bit, although it's again over here. In a La Nina year, and not going to come, sorry, in a neutral year, why such a strong descent is not clear to me. Okay? So that is telling you something else is happening, which is not related to the Pacific. Finally, I look at water vapor. I mean, there's always a much more interesting signal. And water vapor is very interesting. Well above normal, not only over Arabian Sea, India, Africa, Indonesia, of course, and all these places. And compared to this year. Okay? This was great, but last year, this thing was not having so much water vapor. Neither did, of course, India was in a break zone, Africa nothing. So to me, that is also another hint about something different happening. But I can't come up with any plausible theory. But note that this water vapor anomaly in the Equatorial Pacific all the way is consistent with the velocity potential of the rock. Yeah, consistent with what we see here. These two are together, that means something is happening in that region, and second part, which I want to look at, which again, not enough work has been done. See, we always look upon El Nino as being connected to water circulation. Okay? But you look at all the data over the last, I would say, 40 years, when data is good. Sometimes you see things are not quite east-west, they are tilted. And that plays a role. Okay? I've not looked at it in detail, but that is something which has to be examined. As a matter of fact, I mentioned this a couple of years back. There was a work done, I think I can't remember the name. I think Clara Desson, who argued that SST is not a good indicator for El Nino. Okay? It's a very, what do you call, outsider's view. She said that don't go by SST anomaly, because that doesn't tell you the whole story. You have to look at the whole column. Okay? And that is OLA. Okay? So she has redefined El Nino only through OLA, keeping SST out. The only problem, of course, people don't like it because then you can do it only for the last 60 years. When you have satellite data, you go back to 1901, you won't get a hold of it. Okay. So, but I think there is a important point there that just because SST is high over Equatorial Pacific does not guarantee a possible response to it. Something else is required. So you better look at OLR to characterize engine learning and not the SST alone. Okay. Yeah. Okay. Yeah, some discussion going on in many websites trying to explain why non-unit didn't come. You can look it up. And the most interesting part is this for next year. The forecasts are there that next year we're going neutral. Okay? I'm talking about 2025, which is the next monsoon. And so not only that we will not get La Nina will be there for a short time in November, December, Jan, but all the models saying is going to be neutral. Okay, so that is what we'll discuss next week also about that. Yeah, this I have done. Yeah. Now I'll talk about something I covered last time. Last time I talked about my pet argument against correlation. Okay. So I'm going to show you two publications from Nature Journal, which are considered as very good, okay, which are misleading. Okay. The first one was published in 2015, okay, in which they looked at rainfall over this region, which is, a region which is undergoing many droughts. So over the last 100 years, the rainfall has been going down with a multi-decadal cycle. In the same period, the Western Indian Ocean, Equatorial, has been going up. Authors conclude just by this figure that they are correlated. Yeah, they are correlated, of course, but it means nothing. Okay? So they tried to appeal the Atlantic contrast, which I'm totally opposed to. Okay, and then today, there's further confusion amongst all of you who know about it. The original Atlantic contrast of Hadley and Halley is based on surface temperature difference, okay, between India and the surrounding ocean. Now, one can show clearly that after the monsoon, that difference disappears almost. Okay, so it is not worth discussing. So now people are to column mean temperature. This is okay, but column mean temperature is a consequence of monsoon, not cause. You can use column mean temperature to talk about monsoon change. As soon as monsoon is more vigorous, column mean temperature will go up. It has to go up. Okay? So those two are same. They are different quantities. At least SST is reporting. That's a lag. SST has a long what you call inertia. So one can hope SST may be able to predict monsoon. So you take a column mean temperature, it has no inertia. It is instantly responding to your monsoon. Okay. So they talk about column mean temperature over India and over surrounding ocean. But that doesn't mean anything. Okay. So that's one example. Now this is remember to prove the decline in rainfall over India. Let's look at this period because I'm going to talk about next paper. So this 15 paper, few years later, another Nature journal published another paper which we discussed a couple of years ago. And the major defect of this paper is it started 2002. Okay? This is a methodology never start in a drought year. Okay? An extreme year is not the way to start a discussion. Because you start an extreme year, every year later on will be better, obviously. So they claim they have found the revival of the Indian monsoon in 2002. So to me, that's the wrong start. You never do analysis of this kind, starting with the worst year for the last 50 years. Or something to the last 30 years. So the whole argument is wrong, but to be surprised, they also talk about Atlantic contrast with the same logic, and all of this is wrong, but published by two Nature publications. So you have known that today, a lot of publications carry no real value. Okay? So you have to be very critical. Don't get influenced by big names and big journals. You look at it, ask whether they have done any convincing argument supporting. So both these people talk about Atlantic contrast, and one claim it explains why monsoon became stronger, other claim monsoon became weaker around the same period. Because the other one was a little longer, but look at the last 20 years. The other paper talks about the decrease in monsoon due to Atlantic contrast. This guy talking about last 20 years also, 2002 to 2000. I think this was 17, few years earlier. And today, both of them are telling us nothing. They are mainly talking about association. Now, let me add one more thing from last week's discussion. I gave this my favorite chart. Algorithms are talking about the making mechanism. Now, this guy is such a great sense of humor. He went to ChatGPT, okay, and asked for the explanation. Can any of you read it? It's a very interesting reading. Okay. So ChatGPT gave him some crazy excuse. Now, let me tell you in the right way, many published papers are like that. And today you can put ChatGPT and ask for explanation. We put it in a paper, even get it published. So it's getting pretty crazy. Okay? So this guy in his website has many such interesting stories showing that just because something looks good does not mean it is right. Okay? I want to keep reminding you about that. So with that, I'll come to the conclusion that we come to the standard 3-month mean of August. We are still at 0.1. We may go to 0 in July, August, September, I think. But so this year is not a non-linear year. We have gone from El Nino to neutral, and according to Arindam's analysis, in that period, I showed those 20 years. Okay? I calculated the mean rainfall. It is 882 millimeters. Okay, normal rainfall. So IFT was smart in predicting normal year, even if La Nina didn't appear, because that's what the data is showing. For the last 100 years, whenever we went from El Nino to neutral or even La Nina, we add up all those years, we are going to be either normal or just above normal. So that's just climatology, no real skill. Okay. So I want to show you another result here. Last time we discussed how models are not doing well. Recently saw a paper which is the highly centered regional climate model. That means at the high resolution. Yeah, pretty impressive. CFS is not that good. So I would like to know why. This is, I think, 0.5 degree resolution, not very high. And we are getting all these features absolutely right. Okay. So I'm not clear about the main difference between hardly centered regional model and CFS V2, that they are getting the spatial pattern of rainfall very close to. And the reason I'm pointing to you, this is a website, all you look at it. This was started by a very interesting guy in England. Okay. This is called climateprediction.net. I talk about this in my course and I will teach that. So this guy essentially is about 10-15 years back. He wanted to get a lot of simulations done under various conditions of the model. So there was not enough computing power in the university. So he sent an email to all people in England that if you have time on your computer at home, please run this model. Okay? This is not a high resolution model, a resolution model, but now looks like they also do. So look it up. There's a lot of data from that climateprediction.net, this one. Okay? And this paper was published on Marathon drought is based on that data. I find it is quite good for even smaller scale. Okay? So there are some models getting even smaller scale correctly, but although this nice, what surprised me was it didn't get the temperature right. So that again bothers me. You get rainfall right during monsoon, you must get temperature right, because during the monsoon, rainfall controls temperature, not vice versa. Okay? That's very clear. But somehow the temperatures are at least 4 to 5 degrees higher in the observation than in the model. That is a bit puzzling. That worries me. There is some problem with the land part of the model.
Observation issue. The observation issue.
What do you mean?
Observation temperature.
Yeah.
Because they might have taken from reanalysis, I'm not very sure.
Yeah.
Analysis data is again model based, so that
Yeah, you're right. How would even it's quite good, right?
and I don't
No, I checked out. That looks good. One is a check. Yeah, I mean, I'm assuming that I'll go back and check. That it is 2 meter high in both, I hope. Because you can't obviously fit them very easily. But to me, after seeing a very impressive rainfall climatology, to see this difference is very surprising. But I brought this paper only for all of you to look at this location. A lot of data available over a fairly long period. Okay. Yeah, with that, I will close the discussion. Any questions? Okay. So the next week is the last week, which will be just retrospective of this year's monsoon. Nothing very interesting. Let's see what you think I can bring out this year's monsoon. Okay.
This observation is of this observation.